In these videos, we will present a holistic approach to big data, taking both a top-down and a bottom-up approach to questions such as, what is big data? How do we tackle big data? Why are we interested in it? And what is a big data platform? In addition, we'll venture briefly into futures and the role of cloud technology in relation to big data. This slide lists the main topics that we will cover: the state of big data adoption, big data, a holistic approach, 5 high-value big data use cases, technical details of key big data components, the future of big data and cloud, and available resources. The first of these is the current state of big data adoption. For this, we will draw upon a report, Analytics, the real-world use of big data in financial services. The IBM Institute for Business Value partnered with the Saïd Business School at the University of Oxford to conduct the 2012 Big Data at Work survey, the basis for the research study, surveying 1,144 business and IT professionals in 95 countries, including 124 respondents from the banking and financial services markets, or 11% of the global respondent pool. Participants were given a survey where they could provide multiple answers to big data sources and analytics capabilities headings where big data is being used. 88% of the respondents said they use transactions as their big data source. 73% of the respondents said they use log data as their big data source. Because the respondents could choose more than one answer, these values overlap and thus do not sum to 100%. The big data adoption process goes through a number of phases: education, exploration, engagement, and then execution of a strategy. Underneath each block on the chart are percentages of global sectors and the percentages of banking financial management respondents that are at each stage. In this chart, the left column shows sources for big data and the right column what to do with it. Transaction data is existing data that customers say is the main source of big data, and they want a query report on it. In a relational database management system used for transactions, every time you update, delete, insert, and select, this information is logged. The business user can analyze this data for business purposes, not just for recovery purposes. Thus, what is this information being used for? The right column in this case shows querying and reporting. The second entry on the left is log data. Walmart is probably the largest company using radio frequency ID technology to allow it to track everything that it has to deal with around the world. This is sensor data that can be helpful to analyze use and inefficiencies. Thus, is it faster to get supply from north of China than south of Vietnam? Social media, Facebook, Twitter, etc., is number 5. Lots of buzz around it, but not that yet important in the study. It's not that companies are not working on getting Facebook and Twitter data, but the emphasis is mainly on their existing transaction data, ranked number 1, and log data, or machine data, ranked number 2. Mainframe machine data is considered to be trusted data, and based on this data from the mainframe, this is the centerpiece of a big data strategy. Also, Still, images, video, and audio are not yet important, generally as a big data source. But one should note that clinical data, surveillance data, mobile cameras, etc., are actually around 70 to 80% of unstructured data. Currently, you will see analytics capability in the second column of video analytics and voice analytics at the low end of this scale. Big data skills are in high demand, especially Java language and experience with Hadoop distributions. The new profession is data scientist. The data scientist represents an evolution from the business or data analyst roles. The formal training is similar, with a solid foundation typically in computer science and applications, modeling, statistics, analytics, and math. What sets the data scientist apart is strong business acumen, coupled with the ability to communicate findings in both business and IT leaders in a way that can influence how an organization approaches a business challenge. Good data scientists will not just address business problems, they will pick the right problems that have the most value to organizations. The data scientist role has been described as part analyst, part artist. It has been said that a data scientist is someone who is inquisitive, who can stare at data and spot trends. It's almost like a Renaissance individual who really wants to learn and bring change to an organization. Data scientists are inquisitive, exploring, asking questions, doing what-if analysis, question existing assumptions and processes. Armed with data and analytical results, a top-tier data scientist will then communicate informed conclusions and recommendations to an organization's leadership structure. Big data has become a business issue, or at least an issue that business people are aware of. Look at the coverage it's getting in the business press. From the Wall Street Journal, companies are being inundated with data, to the Financial Times article, increasingly businesses are applying analytics to social media such as Facebook and Twitter. On to Forbes. Big data has arrived at Seton Healthcare family. Why is big data getting this type of coverage? Because it has the potential to profoundly affect the way we do business. The quote on CNBC really exemplifies this. Data is the new oil. Data is a natural resource that is growing bigger. Like any resource, it's difficult to extract. It comes in many types or a huge variety. It is also difficult to refine or analyze. Many organizations do not even tap into this natural resource. They ignore data or use it for just one purpose. This is largely because it's difficult to structure and restructure for different purposes. But some organizations have cracked the code and they have figured out how to process and analyze data available to them, and they are utilizing it to achieve breakthrough outcomes. If data is a natural resource, what is your company doing to capitalize on it? Here graphically you can see some of the sources of big data. All forms of data are represented, and all are processed by different types of analytics to yield insight to the business organization. Sensors are one of the biggest contributors of big data, enabling new applications across industries. Examples include telemetrics for auto insurance and vehicle monitoring and service, smart metering for energy and utility organizations, inventory management and asset tracking in the retail and manufacturing sectors, and fleet management in logistics and transportation organizations. Applications that rely on sensor-generated data have unique big data requirements to efficiently collect, store, and analyze the data to take advantage of its value. Weblog and database log data are major producers of machine-generated data. Let's look at some other examples of sensor and machine-generated data to expand our perspective. There are 4 engines on the Airbus A380, the double-deck largest commercial airplane in the world. Each A380 engine generates 1 petabyte of data on a flight, for example, from London to Singapore. The Large Hadron Collider, when operational last year, generated 1 gigabyte of data every second. A new radio telescope, called the Square Kilometre Array, is currently being built in the Southern Hemisphere. The SKA will produce 20,000 petabytes per day in the year 2020, compared with the current internet volume of 300 petabytes a day. This is predicted to grow by a factor of 10 when fully operational in 2028. The various data centers to process it will each handle 100 petabytes of data per day. You have now completed this video. In the next video, we'll look at big data as a platform and not just a collection of disjoint software packages. We will take a holistic approach to this big data platform.